Hello, in this video we're going to look at our third technique for solving Minesweeper. So we've done all these simple solutions by checking that we've got the right number of mines around each square, but now we've got to the point where we can't solve it simply. So now what we're going to have to do is guess. So what I mean by that is we'll take a square and we'll play a mine in that square, and then we'll play forward as far as we can until we get to an invalid state. If we've got to an invalid state, then we know that the original square couldn't be in a mine. Likewise, we can do it the other way around. We can say that the initial square is empty and we play forward, and if we get to an invalid state, then we know it must contain a mine. So we've done our first two methods. So in here, what we need to do is loop over all the empty squares. So we're looking over all the squares, all the cells. So if it's empty, no, if it's unknown, so first of all we'll try playing it as a mine. So we probably actually need to put this into its own method as well. Which can work in the same way as the others. Yeah, basically the same as the others, isn't it? Okay. Okay, so we set it to a mine, then we play forward until we get to an invalid state. So we can use our game validator to check when it's invalid state or not. So what we're saying, if the board isn't valid, which it will be at this point, but if it wasn't, oh, yeah, if the game's not valid, then we can return a solution because we know. So the solved cell is just that one. Description is cannot contain a mine. The cells of interest, we don't really have one. What's this return? Oh yeah, okay. Okay, so the other thing we need to do is unpick that, because now we know that cell's empty. Can't contain a mine, so it must be empty. Okay, so that's the base of it. However, we need to put some code in here because we've made that move, but we do need to play the board forward until we get to a point where it's not valid. So, how are we going to do this? I think we need to keep playing those two methods. So we play method 1, we then validate the board, what do we say? Yeah, if it did something, we play the first method, if we did something we then validate the board. Yeah, not that either. If it didn't do anything, yeah, it's better. Play the first method. If that didn't solve anything, we then play the second method. If the second method did, if either method did something, then we do our validation code. Otherwise, we go through and we do another go. We can keep doing that until we don't have a solution, so solution is null. So after a while we actually want to do while, don't we? So it's going to be so when we find an empty cell, an unknown cell, we pretend it's a mine. We then try solving it with the first method. If we don't get a solution, we try the second method. If either returned anything, then we check the board's still valid. If it's no longer valid, we know our original assumption was wrong, so we undo that, and then we quit. If solution is null, if solution is not null, it means we made a move, so we go again, otherwise we can quit. So the thing two things are missing. If we get to the point where the solution is null, it means we can't play any further. So that means we don't know what that cell was. So we just need to put it back to unknown. And the other thing we need to do is every time we make a move, we also need to be able to undo those as well. So we need to keep track of all the moves we've made. So we need something moves to do and list. Yeah, we'll just do that in here. And there's two places we need to undo the moves. One was in here. So that's going to be unknown again. And we need to do, so when we get to an invalid state we need to unpick it, and equally if we don't ever get anywhere we need to undo it. Well, let's see what that does. So it thinks that can't contain. So it thinks that can't contain a mine. So if that was a mine, then that can't contain a mine, because that would have too many neighbours. So if that can't contain a mine, that one must. So that can't contain the mine, that can't contain a mine, that can't contain. Yeah, so that contains a mine. None of those three can contain mines. However, then this one now becomes invalid because this has to have 4 neighbours. Yes, that's worked. I think we've solved as far as we can go. So down here, I don't think we can solve this. These are unknown squares. So the only other version we can do is this one in reverse, where instead of placing a mine originally, we say the square is empty. This code's a bit messy, but for the moment I will just copy it. And method 4. What we do is we change method 3 so we can actually see it in action. So we're saying the cell is unknown, unknown we said empty. If we get to an invalid point, it must contain a mine, and contains a mine. This is into a loop. look at the call spec. No. No solution. One solution is, it's back to fun, isn't it? I think we must be lucky before that worked. Need to fix it down here as well. Try again. Okay. So that must contain that one must contain a mine. So if that didn't contain a mine, if that didn't contain a mine, well then that one must contain a mine, which means that can't contain a mine, and that's invalid. Yep, so that seems to work as well. Right, so next time we'll look at using a different board to make sure we can solve some other games as well.